speed.
Professor Montagnier, you and your team at the Institute Pasteur first discovered a virus which we today call HIV and is thought to be the cause of AIDS. Have you always believed that it was sufficient on its own to cause AIDS?
At first, yes, we thought we had the best candidate for this virus to be the cause of AIDS. But after a while, even from the beginning actually, we thought maybe for the activation of that virus in cells, we need some cofactors. And for instance, we still know very well that the lymphocytes, which are the main target of the virus, can replicate only the virus when they are themselves activated. And any kind of antigen can activate lymphocytes. So we thought perhaps a continuous activation by many infectious antigens, for instance, could increase the burden of the virus infection. This was the first thought. After that, we thought that perhaps some factors coming from the body itself, so-called autoimmune factors, could also amplify the effect of the virus. And finally, more recently, we think that some infectious cofactors may also play a very crucial role.
These cofactors, what are they? Do we know?
We believe to think some of them at least are what we call mycoplasmas. Mycoplasmas are very small bacteria which normally lives on the surface of cells, of tissues. They are parasites. They cannot live without products coming from the cells, but they are staying outside normally at the surface. They don't go inside like viruses or some other bacteria called Rickettsia or Chlamydia. We thought those mycoplasma could play a role because we found recently that antibiotics, which are active on mycoplasma, like tetracyclines, can suppress the cytopathic effect, the killing effect of the virus on infected lymphocytes. So if we remove the mycoplasma, the virus can still grow very well, it can still replicate in lymphocytes, but does not kill anymore the cells.
Well, given this recent work of yours, are you still convinced that HIV is a cofactor or even necessary to cause AIDS?
That can be debated, I think. Some people think HIV by itself can cause AIDS.
Sorry, Professor.
However,
It's just going off and Nikki's coming back.
I'll stay outside and suffer.
Here she is. Right.
Anything about speed?
We are there?
About speed?
Okay, when you're ready, Michael.
Given this recent work of yours, are you still convinced that HIV is a cofactor or even necessary to cause the disease?
I still believe HIV is the primary agent. Without HIV, I think we should not see AIDS. But perhaps some cofactors are also important. So if you address HIV, you have some kind of benign disease, and the amplification of the clinical signs may be due to the cofactors. That is still in debate, I think. So we can also think that some strains of virus are more violent than some others.
What exactly is a co-agent?
Well, a co-agent means that you need two things to have the disease. One, you have call the virus V, HIV, and the other factor is X. So the equation will be V plus X equal AIDS. Without X, we don't have AIDS. This is one possibility. The other is that the cofactors, the difference between co-agent and cofactor is that if you have a cofactors, you can remove the cofactor and still have the disease caused by the HIV itself. But if we say we have a co-agent, it means this is an obligatory co-agent, cofactors.
Do you have any proof that the mycoplasmas that you have found cooperate directly with HIV?
Yes, we have some laboratory data which are very interesting because they show some synergy between the virus and the mycoplasma. It seems the viral replication is enhanced by the infection, the contamination by mycoplasma at the same time. And what we see in the test tube, of course, has to be proven in patients. We don't say at the present time really this also occurs in patients. But we have some very peculiar, very strange results. And if we, for instance, if we remove completely the mycoplasma by antibiotics, of course we are removing the cytopathic effect, the killing effect of the virus. But also in some cases, the virus replicates less well. And if we add the mycoplasma, we have a very large increase of viral proteins. How this does occur, we really don't know. But this is very interesting to study.
So if you take away the mycoplasma, the virus no longer kills cells. So therefore, is it doing any damage at all?
Well, it could still do some damage. We can see what we call giant cells, because the one protein of the virus can induce fusion between cells. So part of this killing effect still remains with the virus alone.
But this is always in the absence of antibody, isn't it, in a laboratory dish?
Yes, this is in the test tube. If we had antibodies, we could have some killing of the infected cell by the antibody or by cytotoxic cells, which kills the cells which bind the antibody.
I see. In your recent paper in Research in Virology, you found that by getting rid of the contaminating microbe, HIV no longer seemed to kill cells. Doesn't this suggest that it's the microbe that's killing the cells, and HIV is a harmless passenger?
No, I think we can discard that hypothesis, because we also have now isolated pure mycoplasma from its patient or from culture cells, and those mycoplasma have some cytopathic effect on the cell, but not of the same kind as caused by the virus. And actually it's the combination of the two agents, the virus and the mycoplasma, which really induce what we call cytopathic effect of HIV.
The destruction of the cells.
Destruction of the cells.
What proof do you have that AIDS is an infectious disease?
Oh, I think there are many proof of that. Many data accumulated since 1983 indicate that AIDS is a transmissible disease. You can, for instance, have AIDS cases after one single blood transfusion. You can find the HIV, the virus, in the blood donor, and find also the same virus or similar virus in the recipient patient. So it's clear that HIV can be transmitted by blood, and also very well by sexual contact. There are a lot of epidemiological studies indicating that. So I think there is no doubt that AIDS is an infectious disease. It's not a contagious disease, but it's an infectious disease.
With regard to the incubation period, it's now being suggested it might be as long as 15 years. But why should it be so long before HIV is supposed to become pathogenic?
Yeah, this really is very enigmatic, very mysterious. And I believe the cofactor, the coagents we have found may explain part of this very long incubation period. If you think that in order to have this very profound immune depression, which is characterized by AIDS, you need probably a progressive destruction of lymphocytes, and this cannot be brought about only by a few viral particles infecting a few cells. You need a very profound disruption of the immune system, and if you add the coagent, if you have the mycoplasmas, those mycoplasma also induce some kind of immune response, and this could be added to the burden given by the virus. Of course, you can also have more destruction of the cells if you have combination of the two, as we see in the test tube. But you can have also some kind of disturbance of the immune system by the two agents. Of course, we have not proven that. This is just an hypothesis.
Is it not more usual for a microbe to cause a disease as soon as it enters the body, particularly a virus?
Yes, what we call normal, usual viral diseases are caused in a short period of time. You have the example, for instance, of polio infection. You have the example of flu, cold, common cold, in which soon after virus infection you get the disease. But those are viruses, I would say, ordinary viruses. Of course, HIV is a peculiar virus because it is a retrovirus. It means that its genetic material can stay for a long time integrated into the host chromosomes. So this could explain in part why it could induce delay disease. But again, I think another explanation is that perhaps in order to have the disease, you need more than one agent. You need a second infection by mycoplasma or some kind of specific interaction between the virus and mycoplasma in order to have this burst of destruction of cells we see in AIDS patients. So there are many possibilities still. I think we are still in a at the very beginning of understanding AIDS.
What is your view of Peter Duesberg's contention that HIV is a dormant passenger virus that cannot be pathogenic, that it doesn't destroy cells?
Well, according to our recent data, I would agree that HIV, some HIV strains are not destructive for infected cells, so the cells can remain alive for a very long time, and we have actually example of primates, of monkeys, which are infected with virus very similar to HIV, not the same, but very similar, in which you see no disease. The animals can stand very well that kind of infection, even in his blood, in blood lymphocytes. So I would agree that HIV by itself, or some strains of HIV, are not sufficient to induce AIDS. But calling that a passenger virus, this is a further step. I'm not prepared to take that step now. I think we have no data to support this hypothesis. I think all the evidence we have is HIV is necessary, maybe not sufficient, but necessary to induce AIDS.
Do retroviruses usually destroy cells?
No. Usually retroviruses are causing transformation of cells, cancerous transformations, or leukemia, for instance. But there are a few examples in the animal retrovirus which indicates that some retroviruses can kill cells. And this is, for instance, there is an example of that in chicken, a virus of chicken, which kill avian cells. But it has been shown by our Temin and his colleagues that this is due to continuous reinfection of the same cell by new virus particles. This has been also hypothesized in the case of HIV.
How do you feel about the view that AIDS is caused by risk behavior and lifestyle and is not infectious at all?
No, I think if this was the case, we shouldn't have seen no cases after transfusion, because those people which are receiving transfusion are not have a special behavior. They just had accident or surgical operations. It could be you, it could be me. Anybody can receive a blood transfusion and be infected by the AIDS virus. So it has nothing to do with behavior. There is also the example in Africa in which many people are infected by heterosexual contacts, prostitutes and so on. So it's not particular to homosexual behavior, I think.
If you have identified a possible bacterial cofactor, and that can be defeated by an antibiotic like a tetracycline, which has few or any side effects, how do you feel about the widespread use of a very strong and toxic drug like AZT?
Well, I am cautious. I think we can call AZT a very strong toxic drug, but it has been shown also to help. There is no discussion about that. I think for a short time, AZT can help and prolong the life survival of AIDS patients. But we know also it doesn't cure. We know it has some very good effect in the in vitro situation in the test tube, because it prevents the enzyme, the key enzyme, which replicates the virus to act. And we think, but we have not the proof that it also acts in the same way in patients. So this was really a prototype of some kind of antiviral agent working in AIDS. But we know this is not the final solution. And I think now there are in the benches of many laboratories some compounds which are much more active than AZT and perhaps less toxic. But we have to prove they are also active in patients, so this will take time. And I personally believe those drugs will be useful, but not sufficient, again, to cure AIDS. Of course, if there is a coagent like mycoplasma, like small bacteria, we need to combine the antiviral treatment with antibiotic treatment. You mentioned tetracyclines, but we have some preliminary evidence that some mycoplasma strains, which have been isolated from AIDS patients, are rather resistant to tetracyclines. So we also have to do some research to find the best antibiotics active on those mycoplasmas. And this will take time. So I would say the medical solution is there. It will come, but we need some work.
So where do you see AIDS research progressing from here?
Oh, I think we are in a very exciting time because we see, like in 1983, a very fast progression of AIDS research. Of course, this does not help immediately the AIDS patients, but it gives hopes that in a few months, perhaps, we should find some help for them.
And cut. Thank you very, very much indeed. That was absolutely...
Speed.
So where do you see AIDS research proceeding from here?
I think the research now is going very fast. We are in a very exciting time, like in 1983, 1984. You know that research is going step by steps, and we are thinking now to go through another step. But those are laboratory findings, and I won't like to give some false hope to the patients. We don't have anything which can cure AIDS immediately now, but there are hopes for the future. I think this is very important, and I hope by the year 2000 we will get rid of AIDS.
And cut. Thank you.
I want to talk and you just nod.
Yes.
If
Who is this stupid man?
let's do that, sure, okay? You're doing it.
You've done this.
Speed.
Michael, we're doing it. Professor Montagnier, can you look quite serious? Because you were concentrating very hard when Michael was talking. Okay? Michael, you carry on.
So I would imagine this is quite a common occurrence which you get totally included in here a lot of the time because Madame Meunier has said that you're quite a veteran and that the lights are always being put in and taken out, and cameras coming in and coming out, crews from all over the world. So it's really like a television studio here. Is that enough?
Yes, that's wonderful. Right, now, what's the time? Okay, thank you.
We'll just move over there.
No.
We're speeding. Yeah.
Thank you. Lovely. Splendid. Just take one picture of you there because it was all... Thank you.